Hi, we're going to talk about how to complete truth tables for negation, conjunction, and disjunction. But first, what's a truth table? This is a way to organize and analyze what we call truth values of logical statements. And what we're trying to accomplish, as I mentioned in one of my other videos, we're trying not to tie it to a specific situation, not know exactly what the statement says, but rather understand what the outcome of the meaning is. Okay, so let's start with a very basic one. So for each statement that is involved, there are only two outcomes. It can either be true or false. So if you make a very simple statement, then you have P. It can either be true or false. So this is not P. So if P is true, not P will be false. And if P is false, then the not P will be true. That's as simple as that. Okay. So let's talk about a disjunction. Disjunction is a compound statement with or. So that one's going to be true when at least one of those two statements is true. So I'm going to show you a real life example. 3 times 9 equals 27, or 3 plus 9 equals 14. Which is equivalent to, you can also write that with this symbol, 3 times 9 equals 27, or 3 plus 9 equals 14. So we know that 3 times 9 is 27, but 3 plus 9 is not 14. So this one here is false, but because we want or, at least one of them is true, this whole statement is actually true. Even though one of those statements that make it up is false. Okay, so to complete the truth table, now we have two statements. So you need to be careful. The table usually looks like this. It does need to have 4 different outcomes, because for each one of those you can have true or false. So when you combine them together, you're going to get true, true, false, false, true, and false, false. So we want at least one of them to be true, so true will be true. True, false is also true, one of them is true. False, true is also true, one of them is true. And false, false, that one's going to be false. Okay, now we're going to do the truth table for P or not Q. So when you have that, you are going to have P and Q. You need to have another column for not Q. So not Q, we're going to look here, use a different color here. So that's not actually what we need to do, but we do need to have this. So not Q, that's going to be false, false is going to be true, true is going to be false, and false is going to be true. Right? So now when we need to determine the truth values for our final statement, we're just looking at this column here and this column here, right? So true TF, that's going to be true. One of them is true. True, true, true. False, 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 true, true. Okay? So conjunction is a compound statement with and. So this one is more strict. Both statements must be true for that to be true. So I'm going to show you a couple examples here. So we have 3 times 7 is 21 and 3 plus 7 is 10. Both of those things are true. So when we want, we rewrote that symbolically. But if it's 3 times 7 is 21 and 3 plus 7 is 10, this whole thing is true, because both statements are true. But if I give you another statement, 4 times 6 is 24, which is true, and 4 plus 6 is 11, that one's going to be false, because one of those statements that make it up is not true. Okay? So this one's more strict. So let's take a look at the basic truth table for a conjunction. True, true is going to be true, all the other ones will be false. Why? Because at least one of the two statements is going to be false, and that's what a truth table for a conjunction is going to look like. Alright, so for the next one, example 5, we want to complete the truth table for not P and Q. So we, just like in one of the problems earlier, we do need to have not P first. So not P, T will be false, T will be false, F will be true, and F will be true. So now we're working with not P and Q. The order here does not matter. So we have T, F, 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 T, 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 and F, T, F. Remember, this is a conjunction. Both statements must be true for you to get a true as your truth value. Okay, so at least one of them is false, the whole thing's false. Okay. So now we're going to take a look at more complex. Please don't be intimidated by more complex expressions. What it basically is, you have to go gradually. So let me just explain to you what I'm trying to say. So we have to do not, and then P and not Q. So what do we need here? To get to this, we need to have not P, then we have to have not P and not Q, and then we have to negate the whole thing. So we have this extra column for not Q, this extra column for P and not Q, and then the final column for for the negation of the whole thing. All right. So let's do not Q, and just the opposite of Q. So it's going to be F, T, F, T. You're looking at this column and negate them. So P and not Q. So that's these two columns here. P and not Q, TF is going to give you F, TT, T, FF, F, FT, F. But now we're negating that, so not. So we're going to look at this column and change it all to the opposite. True, false, true, true. Okay. So next one, we have not P and Q, and the whole thing is going to be or P. Alright, so not P will be the opposite of P, so it's F, F, T, T. Then we're doing not P and Q, so not P and Q, we're looking at these two columns here for that. So TF and false, FF false, TT true, FT false. And now what we need to do for our last column, I'm going to use a different color here. We're going to use this one or that one, right? It says not P and Q or P. So very carefully, make sure you don't look. If you want, you can cover the other columns. It may be a very helpful thing to do. As a matter of fact, let me demonstrate. So if you cover the columns in the middle, we only need the other two. This will help you avoid any distraction. You won't accidentally look at the wrong thing. So TF is going to be, we have or, so that's true. TF, true. FT is true. And FF is false. Alright? If you this back, that's what your table is going to look like. Alright. So what we're going to do here is we have a verbal statement that we're going to need to write in the form, in a symbolic form, and then we're going to complete the truth table and determine what conditions are going to make it true. So I ate sandwich, Q, you bought a new game. So how do we write this symbolically? I ate sandwich. So I ate sandwich, that's P. And you did not buy a new game, so not Q. So now we need to complete the truth table, but you notice that there's a couple of columns that do not have anything. So these columns are going to have not Q, and then P and not Q. All right. So let's do not Q first. So it's just the opposite of Q. FT, FT. P and not Q, we're looking at this column here and this column here. So TF, F, TT, T, FF, F, FT, F. So this is what we want. We want to know under what conditions it is true. So that condition will be I ate a sandwich and true, you bought a new game. Right? So the only way this statement comes out to be true is when you have T and T. So that's T for P. Well, that's actually F for you did not, yeah. No, you did not buy a computer game. Okay, so this is how it works, and I hope this helps.